Alright, this is a remake of a video that I recorded on Farrer's car with my $20 El Cheapo Walmart video camera. But now that I have Farrer's old HD camera, I'm going to re-record that video on my car in high def. But the subject of high energy ignition has come up in one of the DeLorean Facebook groups, and there's still some confusion, still some fuzziness out there about HEI. Not across the board. Some owners understand it very well, and some other owners are still a little fuzzy on it. So I'm going to try to clear up some of that fuzziness here. A very common misconception is that simply putting an HEI caliber coil, an HEI rated coil on your DeLorean alone, doing that by itself will give you HEI. And that is incorrect. That is indeed part of the puzzle. That's one of the requirements. But there's two other changes that are necessary to give you HEI. HEI is like a three-legged stool. So there are three things that are necessary. And if you leave any one of those three things off, it would be like a stool that only has two legs. Can't stand up. So that is indeed part of the equation, is an HEI caliber coil. But there's two other things that you need. But before I give you those other two, let me give you just a real quick historical synopsis. HEI, high energy ignition, was developed by General Motors in the early 1970s. In fact, the acronym HEI is a General Motors trademark. But prior to the 1970s, car companies used breaker points inside the ignition distributor to turn the coil on and off, to turn the ground on and off from the coil. And breaker points necessarily required that secondary current be limited to 8 to 12,000 volts. Anything more than that, and you would end up welding the points shut. The points arc very, very badly. That's just the nature of the beast. And so to limit that arcing, one of the things that you do is you limit the amount of current that's passing through the points. Well, in the early 70s, General Motors develops breakerless ignition, electronic ignition. There's no breaker points inside the distributor. So that gives General Motors the ability to increase secondary spark current. And what they discovered was that simply by increasing secondary voltages that are being used in the ignition system, that their legacy engines that have been carried over from the 1960s, that's one of the ways they're able to help meet the tightening government mandates, fuel economy mandates, emissions mandates, because the higher voltage ignition produces better combustion. In fact, the Society of Automotive Engineers did a study just to see, is this true? They used the General Motors 350 in their study. And they said, and the only thing that they did was experiment with ignition. They tried voltage changes. They also experimented with spark plug designs, experimented with spark plug protrusions. And what the SAE found was that the only variable that had any impact on combustion was the secondary voltages. Spark plug design didn't really have an impact. Spark plug protrusion didn't really have an impact, but the voltages had a definite measurable impact. I think the study was done in like maybe 74, 73, 74. I have it on my Facebook page. You can go and see the study. But anyway, the other car companies took notice of what General Motors was up to, and they developed their own HEI caliper systems. They didn't call them HEI because it's a General Motors trademark, but they all operated with similar characteristics. And that is the reason, if you ever look at the spark plug gap for DeLorean and compare it to domestic automobiles that are being built in 1981, you'll notice that the domestic automobiles have much wider spark plug gaps. Anything from 0.04 to all the way 0.06 inches. Significantly wider than the DeLorean spark plug gap. The DeLorean spark plug gap, 0.024 inches, is much, that's basically a breaker point caliber spark plug gap. See, the way the spark plug gap works, it acts like a voltage regulator, kind of a rudimentary voltage regulator. The wider the gap is, the more voltage will be necessary to jump across the gap. Narrower gap, smaller gap requires less voltage. And once the spark jumps that gap, then that is the most that the coil will ever discharge. Even if the coil is capable of discharging more, it's like closing a circuit. Once you jump the gap, that's it. You need enough voltage to jump the gap, but once you jump the gap, that's it. And the reason that the domestic automobiles have such wider spark plug gaps than a DeLorean does is because they're running much higher secondary voltages. I mean, this is true across the board. You can look at any General Motors product, you can look at any Chrysler product, any Ford product, any American Motors product, and across the board, they have higher or wider spark plug gaps that are being jumped by higher secondary voltage than a DeLorean. DeLorean spark plug gap looks absolutely paltry in comparison. So if you want to run a HEI caliber spark plug gap, real quickly here, let me tell you about a fellow around the corner has I think it's like an 86, 87 GMC pickup truck. And his spark plug gap is 0.06 inches. Okay, that's what's printed on the core support. The sticker on the core support says 0.06 inches from the factory. By comparison, a DeLorean is 0.024 inches. So old Andy is running about almost 3 times a DeLorean spark plug gap. And the only way he's able to do that, obviously, is with much higher secondary current, secondary voltages. So if you want to run HEI caliber ignition on your DeLorean, there are 3 things that you're going to need. First and foremost, you need an HEI caliber coil. Okay, this is a Pertronix 40,000 volt rated coil. That doesn't mean it produces necessarily 40,000 volts. What it means is it is capable of producing 40,000 volts. See, the way the coil works, you got the iron core, then around the iron core are the little secondary windings, and around those are the great big primary windings. And the ratio of secondary windings to primary windings determines how much the coil is able to step up the voltage. It's like a transformer in reverse. So an HEI rated, HEI caliber coil is going to have a higher ratio of secondary to primary windings than a lower rated coil like the Bosch coil. I think the Bosch coil is only rated at 12,000 volts, which means it doesn't necessarily produce 12,000 volts. It means it's capable of producing 12,000 volts, and given the lower input voltages, I don't even think it's that high. I suspect that DeLoreans from the factory were probably running somewhere between 8 and 10,000 volts secondary voltage. Well, this coil here is capable of producing up to 40,000 volts. Protronix also makes a 45,000 volt coil, and I think MSD makes one that's even higher than that, rated. It has a coil that's capable of producing that. But the way the coil works, it's a ratio. It steps up what has been fed into it. So that's the second piece of the puzzle, is voltage into the coil. Okay, this is the DeLorean resistor grid, and you'll notice that this is from my main relay. This is what's ordinarily the white wire. There's the white wire. I have a fuse link on mine. So this is battery to charging voltage, somewhere between 12 and 13.5 volts going in. And this goes out to the coil, and you'll notice I have them connected together on the common terminal. Okay, so it's almost like plugging these directly together. I just use that common terminal to join them together. So my coil is getting battery to charging voltage, somewhere between 12 and 13.5 volts is going into the coil. You cannot do that with the Bosch original coil because it's not capable of handling that. If you look at the Protronix data sheet that comes with your coil, there's a little instruction sheet that comes with your coil, and it clearly states that the coil can handle full charging voltage. So I'm running full charging voltage. Whatever my electrical system is operating at is what's going into the coil. And then because it has this high ratio of windings, secondary windings to primary windings, it's stepping that voltage up to potentially as high as 40,000 volts. And then it's discharging it through a much wider spark plug gap. I run 0.046 inches because that's what Ford was using pretty much across the board in 1981. They had a couple of applications that were 0.044, but either 0.044 to 0.046. I think Ferro's running 0.045. I think he split the difference. But irrespective, my spark plug gap is almost twice as wide as a stock DeLorean spark plug gap. And remember, the spark plug acts like a rudimentary voltage regulator. So the coil is going to continue discharging until it is able to jump that gap, which in my case is almost twice as wide as a stock DeLorean gap. See, if you were to put more voltage going into an HEI coil but not increase the spark plug gap, if you were to leave it at 0.024 inches, you would not have HEI. What you would have is brand new components producing the same amount of secondary current that was necessary when you still had the Bosch coil on there, because the spark plug gap itself determines how much the coil is going to discharge. So that's the third leg of the stool. You got to have more voltage going into an HEI coil, jumping a wider gap. And there's no book spec for this because the engines weren't made. Well, actually there is a book spec for this. The 3.0, when Chrysler started bringing the engine over to put into the Eagle Premiers, I think the Eagle Premier is 0.036, I think. 0.036 or 0.038. The Eagle Premier spark plug gap is significantly wider than the DeLorean and spark plug gap that the car was built with. Same basic engine, but the spark plug gap has been increased. And the reason is because they're not running the Bosch ignition system. They have a totally different Renix engine management system. And so part of that was widening the spark plug gap. So those are the three things you need. More voltage into an HEI coil, jumping a wider gap. And I promise you, it works like a charm. I've been running it for, you know, gosh, what, almost decades now. This car has been as far south as Florida, as far west as New Orleans, as far north as Chicago, and New York. I mean, it's been all over the eastern half of the United States. And been all over the eastern half of the United States, and running HEI the whole way, and haven't had a lick of trouble. And if the Society of Automotive Engineers is to be believed, remember that paper is on my personal Facebook page, so you can go there and look at it. I'm getting better combustion simply by changing my secondary spark voltages, increasing my secondary spark voltages. Assuming that the lessons of a Chevy 350 can be applied to a DeLorean PRV. So that is HEI.